Hi there, and welcome to this lesson. In this lesson, we'll be learning about Pythagoras' theorem, okay? And under Pythagoras' theorem, we'll be learning about the sides of a right-angled triangle. So, Pythagoras' theorem is actually really simple. Don't let the word Pythagoras put you off. Basically, it's a very simple principle, and we'll get to it shortly. Now, as the lesson progresses, anything you don't understand, be sure to contact your tutor, who would be more than happy to help. So yes, let's jump right into the lesson. Now, Pythagoras' theorem, the sides of a right-angled triangle. Now, what exactly is Pythagoras' theorem? Now, Pythagoras was a person, okay, and he developed a theorem, okay. So he did some research and he came up with this idea, all right. And basically, his research was regarding the sides of a right-angled triangle. And what he said, this is what he said. He said that given a right-angled triangle, the square of the longest side would always equal the sum of the squares of the other two sides. Interesting. Yeah, so basically, if you have with what, according to Pythagoras, if you have a right angle triangle like this, okay, you always have this longest side, and the longest side is always a slant side, and we call this side the hypotenuse. Okay, don't let these big words confuse you. You just need to learn one very simple thing here. So this longest side is called the hypotenuse, and then the horizontal side is the adjacent, and the vertical side is the opposite. So we have a right angle triangle, has three sides. It has a vertical side called the opposite, the horizontal side called the adjacent, and then the slant side called the hypotenuse. And according to Pythagoras, this man Pythagoras, the square of the hypotenuse, which is always the longest side, remember the slant side is always the longest side, equals the square of the adjacent plus the square of the opposite. Okay, so the square of the hypotenuse equals the square of the adjacent plus the square of the opposite, and that is quite simply Pythagoras' theorem. Okay, it's as simple as that. H squared equals a squared plus o squared. All right, and now let's do something here. So we have this right angle triangle. Okay, we have instances where you'd be given a right angle triangle, you'd be given two of the sides, and you're asked to find the third side. Okay, and what you do is you apply Pythagoras' theorem. Now, given this right angle triangle, you have a right angle triangle like this, and you have the vertical side is 3, the horizontal side is 4, and we're looking for the slant side, the hypotenuse. And quite simply, we're going to apply Pythagoras' theorem, which states that h squared, the slant side, the square of the slant side, equals the square of the horizontal side, a squared, plus the square of the vertical side, o squared. Okay, and then we just put in this case, we're looking for h. We have that a is 4 and o is 3. So we just put those values into the formula, and what we have is we have that h squared equals 4 squared plus 3 squared. Okay, so h squared equals 4 squared plus 3 squared, and 4 squared is 16, 3 squared is 9, so we have h squared equals 16 plus 9. Okay, and then we have that h squared, 16 plus 9 is 25, h squared is 25, and if h squared is 25, that is h times h would give you 25, then the h would equal the square root of 25. So we have that h equals root 25, we have that h equals 5. Okay, and that's it. Pythagoras' theorem, pretty much all there is to it. Okay, and very interesting. Okay, if you get a ruler right now, okay, and you draw a right angle triangle, you draw one side horizontal, one side vertical up 3 centimeters, okay, and then the other side horizontal 4 centimeters, and then you join the ends. Basically, just draw this right angle triangle and join the ends of the two lines. I can guarantee you that once you measure that line, you would actually end up with 5 centimeters. Okay, so you can go ahead and try that. All right, but then now we'll do some examples. Okay, so we have an example here, example 1, and example 1 says solve for the missing side of the right angle triangle below. So in this case, we've been given the horizontal side and the vertical side, and we've been asked to find the slant side. So the adjacent and the opposite, we're looking to solve for the hypotenuse. So From Pythagoras' theorem, we have that h squared equals a squared plus o squared. Okay, and then we just identify our values, our parameters. We have that h in this case is what we're looking for. A is the horizontal side 8 and o equals 6. Okay, very simple. And then we just plug those numbers into the formula. H squared equals a squared plus o squared. So h squared equals 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36. H squared equals 64 plus 36, which gives you 100. And you have that h is the square root of 100. You have that h equals 10. Very simple, very straightforward. Okay, and similarly, if you drew this right angle triangle, 6 centimeters going up 8 centimeters horizontally, you would definitely end up with the length of the slant side as 10 centimeters. Now, example 2. And example 2 states, basically we have example 2 says solve the missing side in the right angle triangle below. So we have, this time we're given the slant side. We're also given the vertical side. Okay, so we have the hypotenuse, we have the opposite, and in this case we're looking for the adjacent. So we have that h squared equals a squared plus o squared. Okay, but this time we're actually looking for a, so we'll just rearrange that formula. If h squared equals a squared plus o squared, to find a, you have that a squared equals h squared minus o squared. Okay, so you just subtract the square of the opposite from the square of the hypotenuse. It will give you the square of the adjacent. Okay, and then we identify our values. H is 13, a is what we're looking for, o is 5, and then we put all of that information into the formula. We have that a squared equals 13 squared minus 5 squared. Okay, and then a squared equals 169 minus 25. A squared equals 144. A is the root of 144, and you have that a is 12. Final example, example 3. And example 3 is asked us to solve for the missing side in the right angle triangle below. Okay, so which is the hypotenuse, which is the adjacent, which is the opposite? Basically, we have this triangle. This triangle has just been rotated a bit. Okay, so we can actually turn this triangle properly so it looks like the right angle triangle we've been dealing with. And if we flip this, basically we have the triangle looking like this. All right, and you can now see clearly that you're looking for the opposite. Okay, you have the hypotenuse as 17, and then you have the adjacent as 15, and you just go ahead and apply the same formula. Okay, and this time we're looking for the opposite. We have that o squared equals h squared minus a squared, and then you just put h squared equals 17, h equals 17, a equals 15, and o is what we're looking for. And then you just go ahead and put all of those values into the formula, and you should end up with o as 8. Okay, so we have that o in this case is 8. And yes, that is how you solve the sides of a right angle triangle using Pythagoras' theorem. You can now go ahead and solve the questions on the worksheet. Bye for now.